If a spacecraft were to run out of power deep in space, it wouldn't fall in the traditional sense, because there's no gravity in deep space. As Newton once said, an object will remain in motion unless acted upon by an external force. In the vast emptiness of space, this force is usually gravity. Without any gravitational influences, the spacecraft would continue to travel on its current trajectory, propelled by inertia. It would keep moving through deep space indefinitely until cosmic radiation or space debris eventually damages it, or unless it encounters something with a gravitational pull, like a planet or a star. The likelihood of these events depends on the spacecraft's location and trajectory. Onboard Voyager 1 is the golden record, which isn't actually made of gold, but is a shiny gold-colored plate containing sounds and images that describe life on Earth. It was designed as a message in case Voyager encounters extraterrestrial life. The record includes greetings in multiple languages, music from Earth, and natural sounds like birds singing and wind blowing. As Voyager moves farther from Earth, its signal weakens, and eventually, it will be too faint to detect. The spacecraft is also running out of power, with its systems gradually shutting down. By 2025, we will lose contact with it, but it will continue its journey indefinitely on inertia. Its design ensures it can last a long time, and although the chances of it encountering anything significant are low, it might still continue traveling through space for billions of years, possibly even outliving the Sun. A similar fate awaits Voyager 2, which will continue its journey, transmitting data while in interstellar space. Before eventually ceasing to function, both spacecraft will become silent artifacts, drifting through the Milky Way. Spacecraft that remain in Earth's orbit, but have finished their missions, are often directed to a remote part of the South Pacific Ocean, known as the Spacecraft Cemetery or the South Pacific Uninhabited Area, located near Point Nemo, the most distant point from any land. This area serves as a safe final resting place for spacecraft that are too large to burn up during re-entry. The goal is to avoid potential harm during their return to Earth. However, there are concerns about the environmental impact of this spacecraft cemetery, as spacecraft often leak chemicals, like hydrazine, a dangerous rocket fuel, into the ocean. While efforts have been made to mitigate these risks, it's difficult to determine the exact environmental effects. Meanwhile, space debris remains a significant issue, with over 27,000 pieces of space debris orbiting Earth. This poses a danger to both manned and unmanned missions. While smaller debris often burns up upon re-entry, larger objects can cause harm or create more debris if they break apart or collide with other objects. To tackle this problem, scientists are exploring new methods to safely remove retired spacecraft. For example, they are considering magnetic arms or nets to capture debris. Another innovation is reusable spacecraft, such as the Space Shuttle, Dream Chaser or SpaceX Dragon, which can be used multiple times. These spacecraft have special systems that allow them to return to Earth safely after their missions, including heat shields and engines that control their re-entry into the atmosphere. Voyager 2, for example, had a radio malfunction in 1978 that was fixed by engineers, using backup system allowing it to continue its journey. Similarly, the Hubble Space Telescope, which initially had blurry images after its 1990 launch, was repaired in space in 1993 using corrective mirrors. Since then, it has provided breathtaking views of the universe. In the world of space exploration, even challenges can lead to innovative solutions, allowing spacecraft to continue their missions long after they were expected to stop. Follow for more content.